Hi. So today in this class, we will talk about how to calculate the average value of alternating current, right? In the previous lesson, we learned the difference between direct current and alternating current, DC circuit, direct current, DC, and alternating current, AC. In the previous lecture, we learned about that. Today, the most we will focus on how to calculate the average value of alternating current, right? And again, in the next, I think I will finish in this lesson, or I will take one more lesson to calculate RMS value, root mean square value of alternating current. And I will tell you why we are using RMS value to calculate the current, the energy dissipated in alternate in AC circuit, right? So before begin to the lesson, I want to tell you that this topic is very important for AP physics, those who are preparing for pre-university or medicine or engineering. So this topic is very important for them. And also British curriculum A-level physics. This is very important for those who are preparing for. I will cover a few topics from IB diploma, high-level physics, right? So let us begin the class now. In the previous class, we talked about direct current. A few things I want to tell you about direct current. So if I ask you direct current, if I ask the expression, you will write I is equal to Q upon T. This is the expression we use for direct current. And direct current is always unidirectional. It always flows in one direction, right? So, and its value may be changing, and maybe increasing or decreasing, but it always flows in one direction. And its polarity remain constant. Its positive terminal and negative terminal is always constant. If I talk about alternating current, and alternating current is generated. If I write its expression, I stands for alternating current. I is equal to I naught sine omega, right? So this is what I naught sine omega t is the general expression for alternating current. And remember, alternating current is generated through a generator or a dynamo, right? And alternating current always changes its direction. And sometimes some writers, they say it is bidirectional flow because it changes its direction as, the dynamo, the armature rotates inside the generator. Okay. And it changes its polarity, and, the charge particles oscillate through and back and forth direction, right? So this is a short detail about alternating current. And as I told you, the expression for alternating current we use is IT, that is instantaneous current at any instance. So we use IT. So instantaneous current is I naught sine omega t. And I want to highlight what the terms stands here. So this IT stands for instantaneous current, and I naught is the peak value. If you see this sinusoidal wave, so this I naught is the peak value and I is the current at any instance. Okay. So if you are going to calculate the current at any instance, we use this expression I is equal to I naught sine omega t, and where omega stands for angular frequency and omega is 2 pi f, 2 pi f, right? And this t stands for what? Time period, and the time period is the reciprocal of frequency, and the expression I have written here. Okay, these are the few detail. Now let us go to the main calculation I want to show you now. One thing we remember, if I ask you current, average current, then you can write total charge upon total time, right? But if I ask you instantaneous current, so I is equal to dq upon dt. Yes, are you with me? Right. But in the case of alternating current, already I told you that alternating current expression means the instantaneous current is always I naught sine omega t, right? Now let us focus, very important point. So this I, which is equal to dq upon dt. So if I ask you dq, can I write I dt? Answer is yes, I can write. Okay. So if I want total q, means total charge, can I integrate both sides? So if I integrate both the side, right? If I integrate both the side, can I get q which is equal to integration of I dt? This is very important point. right? Now, in the case of average current, so I average, can I write integration of I dt upon t, right? And remember, this t also I can write integration of dt. This is very important expression, right? If you want to calculate if you want to calculate average value of any physical quantity, if it is depending upon time, then we can use this expression. This is very important. Once again, I'm telling. So I average, because current depends upon time. So I average, which is equal to, we can write in the form of integration of I dt upon integration of dt, right? And some writer, so they in place of integration of dt, they can write t. That is not a problem. So you can write average value. So if you want average value of any physical quantity which is depending upon time, we can write integration of I of that physical quantity with respect means upon integration of dt, right? One more example I want to tell you, that power is also a physical quantity which is depending upon time. If you want average power, you can write integration of t dt upon integration of dt, right? Any physical quantity which is depending upon what you call it, time. So then, for example, if x is a physical quantity, if you want to find out its average value and this physical quantity is depending upon time dependence, so then you can write, if you want its average value, you can write integration of x dt, very important point, and integration of dt, or in place of integration of dt, so you can write the total time t, right? Okay, so this is the expression we use to find out the average value of any physical quantity, right? Now let us move ahead. Okay, so I have given here the expression how to find out the average value of any physical quantity. So you can have a look. I explained here very neatly. So alternating current is sinusoidal in nature. So let me write and explain you here. Okay, so since we want average current, so we can write I dt upon integration of dt. Answer is yes. And we will calculate for full cycle and half cycle. Look here. So if I talk about full cycle, in full cycle, the total time is t, means starting from 0 to t. And when we are going to calculate about half cycle, so at that time, I will take time from 0 to t upon 2, the half of t. So the t is the total time duration, and half of the t is what? The half of the time, right? So then I will calculate the average current in full cycle for time starting from 0 to t, and for half cycle we will take from 0 to half of t, right? So now in the case of full cycle, so the integration will start from 0 to t, and in place of instantaneous I, can I write I naught sine omega t, again dt, and upon, so in place of this dt, can I write t? Answer is yes, we can write. So in the next step, I can write, so 1 upon t, then integration of I naught sine omega t dt, right? So here I naught is the peak value and which is constant. Then I'm going to show you here. So this integration starts from 1 upon t. Yes, I explained you here. Then starting from 0 to t, then sine I naught sine omega. So I naught is the constant. So this can be taken outside. So in the next step, we find I naught upon t. Yes. Now, the integration of sine omega t is minus cos omega t, right? So when you go for the integration, so sine omega t is becoming minus cos omega t, and this omega t, the integration, we get 1 upon omega, right? So then this range is starting from 0 to t. Once we'll put the value of t here, and next we'll put the value of 0 here, right? So when we put that value of t, we can use this t here. In the next step, we can put the value of 0. Now, as I told you, the value of omega, right? So the omega I told you here, I can show you. Can you see here omega? Omega is 2 pi f, right? So omega is 2 pi f, and this t is 2 pi upon omega, right? So if I put these values here, So if you substitute omega into t, which is becoming 2 pi, so then this value I can put as here 2 pi, right? So then you know that cos 2 pi, its value is becoming 1, and cos 0 is also 1, right? So then if you subtract 1 minus 1, this value is becoming 0. When 0 multiplied with something, its value is becoming 0, right? So then the final answer, so then I average in full cycle is 0. I'm not talking about RMS value. Value is something different, root mean square, right? So this is the average value of AC current, alternating current in full cycle, right? So that means what is the what you call significance? The net transfer of charge is 0. Charge particle only oscillating, right? Only the energy is dissipated, right? So dissipated. So the average charge transfer is, the net charge transfer is 0. I hope you got clear idea. This derivation, you can take the screenshot and you can note down also, right? And I have given also step-by-step explanation here. You can note down for the full cycle, right? Now let us focus on half cycle, and I have given the physical significance. It signifies zero net charge transfer, right? Over one full cycle, the total charge transported forward is equal to the total charge transported to the backward, right? So this is the physical significance. Now let us, but when we are talking about power, then we will use RMS value, because the expression for power is I square T. So there we will use RMS value. And very soon I'm going to explain you about RMS value, right? IRMS and VRMS, I'm going to explain you now very shortly, right? So now in the case of half cycle, the same process, but here the time we will take from, the integration will take from 0 to t upon 2, means half of t. Okay, right? All the expressions same, all the calculations same, but here only one difference you will find. So here omega t upon 2, then when you put the value of omega t, which is 2 pi upon 2, so I have given the expression here, the substitution, then the cos pi is becoming minus 1, right? So when minus 1 and minus 1 is becoming minus 2, when minus 2 multiplied here, you can see the calculation very clearly. Then the average value, I'm not talking about RMS value. The average value is 2 I naught upon pi. And this value is approximately 0.637 I naught. And you know the unit will be amperes, right? So this is how we calculate the average value in AC circuit in alternating current, right? So if you have any question, or if you want any specific explanation, you can write the comment, and definitely I will make a specific lecture for you, right? So then the clear explanation I have given here, if you are calculating average current in half cycle, so this is what 2 I naught upon pi. Similar in the same way, if you are calculating voltage, average potential or voltage, it will be 2 V naught upon pi. The same way we do calculate, right? Next, I have given here one example. It is also I have taken from your past paper. So a sinusoidal AC current is given by the expression 4.0 sine 120 pi t. Remember, right? So omega t is 120 pi. Remember, right? So then what you have to calculate, the total charge between time 2 to time 1 upon 240 second, right? So if you see the calculation, the time period is 2 pi upon omega, which is 2 pi upon 120 pi, so which is equal to 1 upon 60 second, and the time interval is from 0 to 1 upon 240 second, which is t upon 4. Okay, means 1/4 of the total time, right? So if we put all the values here, then you can see the step-by-step calculation I have explained here. And after integration, you know, sine integration is minus cos, then omega t is becoming 120 pi, then the integration from 0 to 1 upon 240, right? After putting all these values, we get the final result is 0.016 0.06 coulomb, right? So this is one question I have taken from your past paper. You can see the final calculation here, right? One more example I'm going to show you here. This is very important. So here the current expression is given here. I is equal to 5.0 sine 100 pi t. If I compare this one, I is equal to I naught sine omega t. Can you tell me? So this I naught is 5 and omega is what, 100 pi. You have to compare all the values, then you can find out the I have written here. So the peak value I naught is 5 ampere and the angular frequency omega is 100 pi radian per second. Then if we put all the values, then finally we can get the answer. I think my screen is clearly visible to all. Then okay, so the finally I naught is the peak value. If you want average value in half cycle, that is 2 I naught upon pi, which magnitude is given here, and RMS value, this one we are going to calculate very shortly, right? So yeah, I think I will now explain about RMS value. So far, if you have any question or anything if you want to ask, you can write in the comment and definitely I will explain you. Now let us start RMS value. How to calculate the RMS value, alternating current, RMS value of alternating current and RMS value of alternating EMF, right? Now let us start.